Throughout this video, we're going to do a desktop computer dissection using 3D animation. We'll journey through the inside of this computer and disassemble every piece of hardware. This video, we disassembled all the hardware inside a typical desktop computer. We desoldered and removed the components from each of the printed circuit boards and took thousands of pictures. Then, using these pictures, we meticulously 3D modeled every single component from the computer case down to the tiniest resistor. As a result, here's all the hardware that we'll explore throughout this video journey with the Central Processing Unit, or CPU, which is the brain of the computer. On top, we have the cover, called an integrated heat spreader, and inside is a smaller metal package that holds the integrated circuit, which is technically called a die. This die is mounted on a printed circuit board that distributes the 1200 connection points to landing pads that interface with the landing grid array on the motherboard. The integrated circuit inside has a few different sections, but perhaps the most recognizable are the 10 cores where programs and instructions are run. Each core is quite complicated. Zoom into a nanoscopic view of the integrated circuit so we can see individual transistors. These transistors are highway, resulting in a computer that can execute billions of operations every second. Let's now zoom out and look at other sections of the CPU. To the side of each, with that in mind, let's move on and look at the motherboard. This motherboard is a massive printed circuit board with thousands of wires running inside and a variety of microchips, components, sockets, ports, slots, headers, and connectors soldered to it. Perhaps the single most important and expensive component, aside from the bare PCB, is the chipset, which is this integrated circuit found underneath a heatsink down here and is connected directly to the system agent section in the CPU. And not as how all computers work. Let's move on and skip over the many different sockets and connectors throughout the motherboard and focus on the voltage regulator module, or VRM, found near the CPU. These components are used to drop the voltage coming from the power supply down to the 1.3 volts used by the CPU. As a result of all the power flowing through these components and their 80 to 90% efficiency, heat sinks need to be placed on top. While we're on the topic of power, a considerable amount of heat, which is taken away by the CPU cooler. This particular cooler uses a pump to circulate liquid through these tubes and into the radiator's channels, which transfers heat to the radiator fins. The fans then help transfer the heat to the air, and the cooled liquid returns to the pump via the return loop. The pump is a brushless DC motor, constructed from a PCB, a control chip, and a stator on the dry side, a barrier in the middle, and then the permanent magnet rotor and impeller on the liquid side. There's no mechanical connection between the rotor and stator, thereby preventing any leaks of the cooling liquid. Let's move on to the power supply, which distributes power throughout the computer. In here, the main transformer reduces the voltage and bridges the isolation boundary between the primary side high voltage and the secondary side lower voltages used throughout your computer. Here's the control PCB that ensures a stable output voltage and sends adjustment signals to the switching power transistor on the primary side using opto-isolators. There are dozens of other components used to filter the input voltage and generate various output voltages, which are then sent to all the different hardware in your computer. For example, an SSD consumes just a few watts, and the connector uses these voltages, whereas your GPU can consume hundreds of watts using these connectors and these voltages. Next, we'll explore the GPU, but before that, let's take a step back and consider the technology we've covered thus far. Alone, each of these components doesn't do much at all, but when united, they combine to form a powerful system. Similarly, let's get back to dissecting this computer and move on to the graphics card and GPU, which is also the brain of the computer. Well, actually, this analogy doesn't really work very well, but anyway. Opening the graphics card, we see another PCB with the GPU's integrated circuit in the center. VRAM chips all around, and the voltage regulator module on the side. Above the IC is a heatsink with a fan to dissipate heat, and on the side of the graphics card are HDMI and display ports, a PCIe interface, and then on the other side is the input power connector. Let's focus on the GPU integrated circuit, which, similar to the CPU, has more than 1,000 solder pads that connected to the PC. Close this graphics card and talk briefly about the 3D model. Note that this is a slightly older model graphics card because we buy most of our hardware as non-functioning parts from eBay, and then, as shown earlier, we tear them down rather destructively in order to accurately model everything. Additionally, sometimes components shown aren't compatible, such as this motherboard that says DDR4, while the DRAM is DDR5. That said, modeling and animating everything to make it feel like you're actually inside a computer took us around 500 hours, and we would greatly appreciate it if you could take a few solid-state drives and hard drives. We're not going to spend too long because we have an entire series of videos on solid-state drives, and then separate videos covering DRAM and hard drives. But quickly, the CPU communicates directly with the DRAM through memory channels running inside the motherboard. Inside each of these 8 DRAM chips, only 16 gigabytes of data can be temporarily stored. Take a look at our 30 SSDs, which permanently store data in 3D array NVMe and SATA SSD. Both have a few 3D NAND data storage chips, a DRAM chip for buffering and holding the data mapping table, and a controller chip. Let's move on and dissect the hard disk drive. Here we have a disk mounted to a spindle with a motor that rotates the disk at thousands of RPM. A read-write head moves across the disk in order to access a single track out of 500,000 other data tracks. Let's zoom in. This drive is even slower than the SSD, taking a few milliseconds to access, thus resulting in slower read and write times, but costing less per terabyte of storage. Thus, we've covered all the hardware inside your computer. So, thanks for watching this far. And as a bonus, here's what it looks like inside a computer mouse with the scroll wheel up top, the infrared light, image sensor, and multiple lenses down here, and the battery and processor in the middle. For computer mice, we have separate dedicated videos exploring the image sensor and scroll wheel with incredible details. Additionally, here's what it looks like inside a basic keyboard, with plastic traces that carry electricity to each key, and when pressed, that key completes a circuit which is sensed by the processor up here. That's pretty much it for what it looks like inside your computer.